Okay, seeing as it is now 1 o'clock on the East Coast, we'll go ahead and get started. Thank you all for joining us today. My name is Chris Soley, and I'm the webinar coordinator for the Center for Disaster Research and Education here at Millersville University. This is our third webinar in our series entitled 90%. Today we are privileged to have Mr. Chris Steuer, the Sustainability Manager here at MU. He will be speaking on the topic of Millersville University's climate change response. As MU's Sustainability Manager, he oversees programs and initiatives focused on advancing campus sustainability. Mr. Steuer assisted in developing the university's climate action plan and is currently involved in implementing the university's greenhouse gas mitigation strategies. Prior to joining Millersville University, Mr. Steuer was a senior sustainability consultant for ICF International, wherein he assisted various public and private sector clients in preparing climate change response strategies, including the National Park Service, U.S. House of Representatives, and the Department of Veterans Affairs. Mr. Steuer holds a Bachelor of Science and Master of Science in Geography from the Pennsylvania State University. And now I'm honored to turn it over to Mr. Chris Steuer.
All right. Thank you, Chris, and thank you, everybody, for having me here today. As Chris said, I'm going to talk a little bit about Millersville's climate change response. So to do that, I will start off with a quote from Dr. James Hansen of NASA, wherein he says that global warming has reached a level such that we can ascribe with a high degree of confidence a cause and effect relationship between the greenhouse effect and observed warming. Says it is already happening now. And that was testimony by Dr. James Hansen to Congress, to the Senate Energy and Natural Resources Committee. But what I think is notable about that testimony is that it happened in June of 1988. So I like to transition over to where I was in 1988. This is a picture of me at my childhood home in Reading, Pennsylvania, after I had drank probably about a 2-liter of root beer. So I had a lot of energy in me that I needed to get out. Around that same time, in 1988, globally, human-induced or anthropogenic carbon dioxide emissions were roughly 21 gigatons that we were emitting to the atmosphere every year. Those human-induced emissions were coming from fossil fuel combustion to generate electricity, things like coal, natural gas, using gasoline in our vehicles, and other sources such as methane emissions from the decomposition of waste in landfills. Since that time, our global anthropogenic emissions have nearly doubled, going from about 21 gigatons annually to about 37 gigatons annually. What's notable about this is that, carbon dioxide, as you all know, is a greenhouse gas in and of itself. It's not a bad thing in the atmosphere. It acts as a warming blanket around the Earth. But if too much carbon dioxide is pumped into the atmosphere, it's comparable to pumping too much root beer into a 9-year-old Chris. Basically, there's going to be too much energy, and all that energy needs to come out. We see the way that energy comes out in the form of climate change, in the form of climate impacts. And types of impacts that we see include rising temperatures that lead to heat waves and drought. We see it in the form of extreme precipitation that leads to floods, and we see it in the form of extreme weather events, which I think would be particularly sort of notable for this audience, where on a day-to-day basis you're going to be focused on emergency management, disaster management, emergency response. Those extreme weather events are going to be, your focus on a day-to-day basis. And increasingly, as we see that energy manifests itself as these different climate impacts, there's going to be an increasing focus on the response that we need to take to deal with them. At the same time, we're seeing compounding factors that make the response to climate change perhaps more challenging. Things like aging infrastructure, global interdependencies. An example of that would be, the conflict that we now see in Syria, wherein some would sort of position that is at least enhanced by a drought that was happening in rural areas in Syria, which was cutting down on food availability. It was forcing more rural populations into the cities. The cities also had food shortages, weren't able to sort of accommodate the need. There's social unrest, a government that's not equipped to handle the social unrest. You have other migratory communities coming into Syria from Iraq and ultimately leading to mass migrations into Europe and to the United States. So we are a global community that can be affected by things as regional as droughts in the rural areas of Syria. Other compounding factors that we see are constrained budgets. Increasingly, we're seeing governments around the world that are less sort of positioned to be able to pay for the costs of these aging infrastructure and other sort of fiscal challenges that they face. We see shifting demographics in the United States. The older adults, the population of older adults is expected to double by 2050. And I think for emergency managers, emergency response, those demographic shifts could be of concern because some of those demographic shifts will be populations that require greater need. We're also seeing and associated with climate impacts the spread of disease, especially vector-borne disease, wherein mosquitoes and other vectors are able to move further north because of warming temperatures, also the seasons and the summer seasons where you have mosquito season are stretched out longer. There are more warm days. So all of these compounding factors just sort of make it an overlay, or climate change becomes sort of an overlay of these existing factors that I think create situations where there's going to be a specific need for individuals who are capable of responding to these various factors in the future. And so there's frankly a lot of money that goes into supporting our response in these areas. This map is showing the number of billion-dollar weather or climate disasters that have happened in U.S. states from 1980 to 2012, upwards of 50 or so billion-dollar weather events or climate disasters in states such as Texas. And so there's an obvious amount of investment that goes into this, and I think increasingly as you see the U.S. and other countries start to deal with these challenges, there will be more and more funding that's put forth for the planning, what I'll talk about later, sort of increasing our resilience to these challenges so that we're better positioned to respond. So with that, I'd like to talk a little bit about our climate change response, the climate change response here at Millersville and what we're doing with respect to climate change. And that sort of breaks out into two areas, mitigation and resilience. Mitigation is our efforts to limit human-induced climate change, typically by reducing our greenhouse gas emissions, those contributions to climate change. And then resilience is adapting to a changing climate, adapting to the impacts of climate change. And we are taking on both. We started with mitigation, so that's been our primary focus to date, and that's what I'll cover, but I'll also shift in a little bit of our resilience efforts as well. So mitigation really consists of our efforts to reduce greenhouse gas emissions, those contributions to the atmosphere. And there's general consensus now that we need to limit the warming of the atmosphere to 2 degrees Celsius that warming is associated with a certain budget, an amount of carbon dioxide that the atmosphere and the Earth generally can hold from human contributions, and that budget is set at about 2,900 gigatons of carbon dioxide. That budget equates to a 2 degrees rise Celsius in atmospheric temperatures, and that's what we believe we can sort of manage. After that, the climate impacts become increasingly severe. To date, since the Industrial Revolution, human emissions or human contributions have been about 2,000 gigatons of carbon dioxide to the global budget. So that means that we have about 900 gigatons remaining that we're able to contribute. And if you recall from the graph I showed at the beginning of the presentation, we are putting in about 37 gigatons annually. So if we're able to hold steady at 37 gigatons, which in and of itself is a challenge because to date we've been rising, as I showed you in that graphic, ever since the 1980s. But if we are able to hold steady at 37 gigatons, that means that we have 25 years remaining before we've filled up that budget. And beyond that, we go above the 2 degrees rise in Celsius and the climate impacts become more and more severe. So the good news to some extent is that with the Paris Climate Treaty, which was agreed upon last December and actually signed into international law on last Friday, with that treaty, the nations of the world agreed to stay under that 2 degrees Celsius threshold. So there is global consensus at this point to stay at that 2 degrees threshold, and countries will set internal rules about how they will make sure that they're staying under their individual budgets. I should note that the events of this past week with the election have called into question whether or not the U.S. will adhere to its commitments under the Paris Climate Treaty. But here at home, within Millersville, we are doing our part to respond to climate change. In January of this year, so January of 2016, Dr. Anderson signed our climate action plan, which sets a goal for us to be carbon neutral by that critical date of 2040. So to do that, we have to get our emissions down to effectively zero. So it helps to understand where our emissions are coming from now. If we look at our greenhouse gas emission profile, and that profile, shown in the pie chart to the right of your screen, shows that about 65% of our greenhouse gas emissions come from energy usage, from purchased electricity and direct fossil fuel combustion in our buildings. Roughly a little over 20% it come from transportation, either from student commuting to and from campus, or business travel for faculty, staff, and students that are studying abroad, and then faculty, staff commuting. And then about 12% of our emissions are coming from other sources, from waste that we send to landfill, from wastewater we send to a wastewater treatment plant, from use of refrigerants on campus for cooling purposes and refrigeration, so smaller sources. So that's the profile. That's where emissions are coming from, and that's where we need to focus if we are to reduce them. In terms of the total amount of emissions, our emissions are 32,910 metric tons of carbon dioxide equivalent. So it's kind of a funny unit, metric tons of carbon dioxide equivalent. Rather than short tons, we're talking about metric tons, so that's about 2,204 pounds of for every metric ton. And since there are more greenhouse gases than just carbon dioxide, we talk about all of them as though they were carbon dioxide in a carbon dioxide equivalent. And what that means is some greenhouse gases like methane, nitrous oxide, heat the atmosphere more effectively than carbon dioxide, so we have to convert them into a factor as though they were carbon dioxide using a global warming potential. As an example, methane is 21 to 23 times more effective at heating the atmosphere. That's its global warming potential. So 1 pound of methane is equivalent to having 21 pounds of carbon dioxide. That's how we do it, and that's how we come up with that number that's close to 33,000 metric tons of CO2e. That value, as you can see from the graphic on the screen, if you had a car, you had a highway to the moon, drive your average car back and forth 150 times, you generate as many emissions as what Millersville is responsible for annually from those sources. If we look out into the future, out to 2040, of what our emissions are looking like they'll be, it's essentially a flat line if we do nothing, and that's largely because we've gone over a construction hump here at the university, so I have a pretty good sense of what our emissions would be moving forward. But we want to get that down to zero. So within our climate action plan, we set a goal for, well, essentially a strategy for reducing our greenhouse gas emissions as much as possible, and then it will be likely impossible for us to get them down to zero without offsets, so we'll have to offset the remaining emissions. But we'll start with reducing those that we can, the direct emissions, as much as possible. And to understand how we would do that, we did what's called a wedge analysis, wherein we look at where emissions are coming from, the mitigation measures that we can take within each one of those sectors, and sort of parse out what we can do in each area to cut our emissions a little bit through energy conservation measures, through using renewable electricity, and other actions on down the line to build up that overall wedge structure of how we will cut away at our emissions to get us closer to zero. We then, in preparing the climate action plan, grouped those individual wedges as appropriate to come up with 10 overall goals that support carbon neutrality. And I won't read each of these, I'm sure you can do that, but just to give you a sense of them, it begins with things like designing all of our new buildings to meet green building rating system standards, and that starts with the Lombardo Welcome Center, which we will break ground on in the spring, and that will be a net zero energy building, our first on campus. We're also going to be seeking to increase the energy efficiency or the energy use intensity of our existing building portfolio as much as possible, and then on down the line, other actions that address transportation, raising awareness about these issues on campus, and trying to incorporate more of these sort of considerations into our planning and administrative practices, as well as our curriculum. To look a little bit more closely at some of the mitigation strategies, 65% of our emissions are coming from energy, so it really does in many ways makes sense to begin there. That's the largest piece of the pie, and I'm sure, as you can all probably tell from being within our buildings, there's a lot of opportunity there to improve their performance. The way we'll go about doing that really breaks out into 3 buckets of our energy management approach, and they are conservation, efficiency, and renewables. And typically when we look at those 3 buckets, starting with conservation, it's the most cost effective by far. As soon as you flip off the light switch or turn off the computers, you're saving emissions, you're saving energy, you're saving money, and it didn't cost us anything in terms of an investment. And then you move on from there. Energy efficiency measures typically have a payback period ranging from a couple of months up to 10 or 15 years, depending on the type of energy efficiency measure you're putting in place. And then renewables are typically the most expensive, wherein it can cost $200 a ton or more to the amount of money that you have to invest to be able to reduce a ton of emissions. So from a strategic perspective, it makes sense to conserve as much as possible before you would put too much money into renewables, because if you put all the money up front into renewables, you're just paying for energy that you don't need to consume in the first place. So our overall strategy starts with conservation, although we're kind of running these concurrently at different rates. We've started in all of these areas. On the conservation front, for the students and faculty that are on this webinar, you may have seen Ville Unplugged that we launched last year, which is an energy conservation campaign that I'll get into in a little bit more detail soon. We just went through an $11 million upgrade to our electrical infrastructure, which allowed us to meter all of our buildings. So now we can understand the energy that each one of those buildings is using and manage accordingly. And as I said, the Lombardo Center that we'll break ground on in the spring will be us sort of dipping our toes into renewable energy. That building will have a PV array on the roof and will generate as much electricity as it needs. On the conservation/efficiency front, as I mentioned, we just went through an electrical infrastructure upgrade, which is allowing us to track the consumption of individual buildings. And one of the things that I think is notable here, just on the conservation side, and gives you a sense of the potential, is if we compare two buildings on campus, Osborne and Caputo. Last year with Osborne, we started what's called a building drift, which means that overnight, when nobody's in the building, we tell the building not to call for heating or cooling demand depending on the season, and just to let the temperatures drift to rise or to get colder, again, depending on whether you're in the summer or the winter, up until you reach a certain point. And so what you see then, what that does for the building's demand, sort of demonstrated by the top graph there, is that you have this more plateau sort of look to that electricity consumption in the building. And what that is the building's not calling for energy for heating or cooling when nobody's there. And so it is during the day and then it drops off at night. Compare that to Caputo, where we haven't yet implemented this building drift policy, and you see that there it just runs more level 24/7. In implementing this simple procedure at Osborne, just doing that is saving us about 35% of the energy that it would otherwise consume in periods where there's nobody there. We haven't yet applied this to Caputo for good reason. We want to make sure that's done well there because there's more sensitive equipment, there's experiments and other things that we have to be mindful of. But if we did, and if we achieved similarly a 35% reduction there, we'd essentially be saving a ton of carbon dioxide every day. And that would add up to about $20,000 in dollar savings every year. So there's big savings to be had on the energy emissions and dollar front simply by doing basic conservation measures. And we know this now and are able to do it because of our tracking. And so that's why you see campaigns like Ville Unplugged, which happens in the springtime. That's why you see this sort of come about. We know that there's a lot of potential, a lot of opportunity to conserve in different areas through simple things like shutting off the lights when you're leaving a classroom, powering down computers and so forth. At the end of the day, there's so much there, and we want to make sure we're all doing our part to achieve that. So that's the mitigation side with some examples of actions that we're taking to reduce emissions, particularly within energy, but we have other actions we're taking on the transportation front, on the waste front, and you'll see more and more of these as the Climate Action Plan implementation continues to evolve over the next several years. On the resilience side, we're just sort of beginning this process. So last year at this time, fall of 2015, we were finalizing our Climate Action Plan to address mitigation. This year, fall 2016, we're beginning the process of incorporating resilience. And so you may have seen last year around Earth Day, there was a press release noting that Millersville was one of 83 charter signatories to the climate commitment, which is the national commitment within higher education that says not only will we develop a climate action plan that focuses on reducing emissions, we're going to develop a climate action plan that deals with the impacts of climate and builds our resiliency. So we're getting that sort of up and running now and plan to do so, figure out how we will respond over the next several years. What this looks like, the basic framework is developing, obviously because we're at the beginning stages of it. But I think this decision tree or graphic helps to sort of give an understanding of what we'll be doing. And so we'll be looking at Millersville's natural, built, and human environment, and then within each one of those areas, step in and assess the vulnerability of different infrastructure, of different affected populations, different species. And so if we step into the built environment there, and within that, within the infrastructure, which is roads, buildings, grounds, utilities, and stormwater, and just look at buildings, when we build resiliency planning or do resiliency planning, we'll look at the vulnerability of those buildings. And then the building's ability to respond, or the building's ability to respond is part of the vulnerability assessment. So as an example, the first thing we would do is look at potential climate impacts. And we've talked about extreme weather events being an example of climate impact. One interesting one that's come up in the past few years has been, in terms of extreme weather, the cold winters that we had when we had the polar vortex. And that's affected our buildings in that some of the residence halls are at the end of the line for our natural gas lines from UGI. And because they're at the end of the line, they have lower gas pressure. And so the more demand that's placed on those pipelines upstream because people are heating their homes, the lower our pressure gets in the residence halls and the less capable we are at meeting the demand, the heating demand of our buildings. And so you start to see how they can become vulnerable to certain weather events. They have a high degree of exposure because they're affected by the cold. They're sensitive to it. And the question becomes, what's their adaptive capacity? What can we do at times when those buildings aren't able to meet their heating demand to make sure that they can? Do we use space heaters and stuff like that? Do we make sure that we improve the lines so that the pressure is there? Long term, do we transition away to forms of heating like geothermal that don't require natural gas? Those are all the types of strategies that you begin to consider when you're thinking about the resiliency of those buildings with respect to climate change or extreme weather events. So that's just a small example, again, because it's sort of broken down or walked into this decision tree. You can imagine how big the decision tree can get when you're thinking about the natural built and human environment and all the affected populations or structures, species within them. So it can get quite large, and it's going to be a multi-year effort. So in closing, I just wanted to talk a little bit about how you can help. And the way I typically think about this is thinking that everybody has a role to play, ranging from just making good decisions in your day-to-day life all the way through to being a change agent. And how you like to help depends on your level of interest, your value system. Obviously, we'd want everybody to help as much as possible, but there are entry points for different people. So I sort of break these out into decision maker, playmaker, and change maker, and give you a breadth of activities that can fall within them. For faculty, it can be things just like shutting off the lights when you leave the classroom. Very easy decision that can become a habit if it's not already in place, all the way through to thinking about how you can incorporate resiliency into research that might support our climate action plan. For students, it can be simple things like cutting down on the amount of food that you take so there's not food waste if you're not going to eat it, all the way through to coordinating carpools using a partnership that we have with Pennsylvania Commuter Services, which basically does ride matching for commuting. So there's infinitely many different ways that you can help, but I think the point is that it can be as simple as just making good decisions all the way through to being change agents. And if you're on the change agency side and you're interested in joining some of the committees that we have on campus or just interested in talking through how you can get more involved, always feel free to reach out to me. That's what my role here is at Millersville. That's my job, to help support you in doing that. And with particular note on the resiliency side, because that's, again, on the climate planning and our climate change response side, it's something new that's developing that I think is particularly applicable for emergency management, emergency response, disaster management, because the two are so coupled, especially as they relate to extreme weather events and our response to them, that I wanted to give out some specific project ideas that you may want to think about doing if you have the opportunity in any of your classes to do a class project. You know, there's different ways you could help support this effort, and if it comes up, please feel free to reach out to me. I'd love to find places to sort of incorporate your work into what we want to do with our climate action plan. Just a few other ideas that are there. We could do things like work with the city of Lancaster. They've expressed interest with us in doing collaborative resiliency planning. Uh, there are various guidance documents, tools, and other information out there on how to do resiliency planning. We're sort of researching those, deciding what's a good fit for us. So there's lots of different places if you are potentially interested in getting more involved in this sort of work where you could plug in. So I think with that I will sort of wrap up and thank you all for listening in. Again, hope you start to get involved from just simple decisions all the way up to really getting involved in some of our committees and some of the work, and I'll open it up to any questions.
Chris, and just so everybody knows, you can type in the chat box there on the right-hand side of your screen if you don't have access to a microphone, or if you wish not to use the mic button. But Chris, I have a question to start off here. It looked like a significant chunk of the carbon neutral plan were these carbon offsets, such as air travel offsets. And I was just wondering if you could speak a little bit more to that and what is a carbon offset, I guess.
Sure. Yeah, a carbon offset, you basically are paying somebody else to reduce emissions and claiming the benefit of those emissions, emission offsets, the reduced emissions against your own inventory, against your own footprint. And they're beneficial when you're in a position where you really can't reduce your own greenhouse gas emissions anymore, and you need to work with somebody else who is able to do so to sort of get you down closer to zero. For in our case, you can imagine that our buildings are always going to need energy. We'll be able to meet some of that energy, in fact, hopefully much of that energy demand in time through renewable sources, but maybe not all of it. Some of it we might still have to get off of the grid, and maybe that grid still is, the electricity generated on that grid is still being done using carbon sources like coal or natural gas. We would have to find a way to offset the emissions from that purchased electricity in order to be down to zero. When you do that, and for us, we would like to push the offset purchases off into the future because I would rather spend our time making sure we're reducing our direct emissions as much as possible. But when we do that, ideally we'd work locally with so that we can be very close to the project to make sure that we're sure that the emissions are actually being reduced. So you try and work locally on good quality carbon offset projects.
That makes sense. We have a question from Bernd. He says that he works at Dickinson College and sustainability is at the forefront of a lot of our daily activities and strategy moving forward. One of the ways this is accomplished is by integrating sustainability directly into the curriculum for all classes from economics to philosophy to geology. Is this something that Millersville is looking to do as far as integrating the concept of sustainability into the day-to-day classroom learning?
Yes, it is. And so we are doing that already, but not, I would say, as robustly as what other colleges and what some other colleges and universities are. But sustainability is being incorporated and has been for some time into many of our science classes, our geography classes, and others. But we're looking to, as you point out, sort of expand that more into our business classes, education classes. You point out, I think economics is the same here, really working into the breadth of the curriculum. And what we're doing at this point is sort of going through and identifying those classes that are teaching sustainability to some degree or another, and then understanding how much and how they're currently addressing sustainability, and then looking twofold. One, the opportunity to expand that in classes where it's already being taught, and then reach out to classes where it's not and begin to think about how sustainability could be incorporated into that curriculum. So the short answer is yes, we're not as far along as we want to be, and we're sort of assessing how we can do that better right now.
Looks like we have another question from Andrew Yarosh. He says, great presentation. It's great to learn from Millersville University is on its path towards becoming more sustainable. What led you to your interest in sustainability? You have a very unique position here at MU. It seems as if this position is not as common as it should be across the public and private sectors.
Yeah, thanks for the question. So for me, I mean, since I was the kid in that picture of me kind of acting ridiculous at the front of this presentation, I've always really been interested in the natural world, for sure, and that's been with me my whole life. But I think the moment in my life that sort of shot me down this trajectory goes back to when I was in college, and of course I had on human geography, and a professor I had at that time who just was really engaging, and I had to do a senior thesis, and went up to him and said, that I wanted to do the senior thesis working with him, and he gave me two choices: to focus on something he was doing on mapping water flows versus some new stuff he was doing on climate change research. And I chose climate change, and it shot me down a trajectory doing this kind of work. But I would say that it's been not, I don't want to pretend that it was fully deliberate, in that I was always just sort of pulling the thread of where my interests are. So for others that may go down this path, I would say that it's okay not to know exactly what the destination is at this point, and just to follow your curiosity and say yes when the opportunities sort of present themselves in front of you. Increasingly, though, if you do know that you want to get into sustainability, there are more and more structured ways to do that. As an example, just this past spring, the International Society of Sustainability Professionals finally finalized a certification process to become a sustainability professional. And so there are pathways now that even a year ago weren't as clear. And if you're interested in exploring that any further, understanding it, and understanding what opportunities there might be for positions like mine within the corporate world, within higher ed, please reach out. I'm happy to talk about them. I think I've had exposure to a number of those, either through myself or through my colleagues at this point, where I'd be happy to share what's out there.
Thank you. Are there any other questions out there? And while everybody's thinking, I'll ask one more I have, Chris. So I know I don't know exactly how far along we are in the climate action plan, but what do you see as like the most viable, or I guess what's your hunch as far as what alternative energy Millersville will drift more towards? Like, will it be like more wind or solar or geothermal? What do you think is the best path forward as of right now?
I think that the type of renewables we'll be looking into will sort of, I think we'll predominantly be looking into solar and geothermal. Geothermal may come later because we just transitioned away from electric heat to natural gas heat over in some of our major buildings in construction that happened within the past decade, let's say. So immediately transitioning over to geothermal may be more challenging but I see it in that path to 2040. In the near term, the price of solar continues to come down. I track that pretty closely. When I started here about a year ago, it was at roughly $4 a watt to install PV arrays, and it's down to roughly $2.30 or so now. So there will be along the way, it's definitely something we're watching and the right thing to do. It's just a matter of understanding the application, exactly how we would go about that. And while we're considering different opportunities, the price continues to get better and the technologies available continue to get better. So in many ways, it's just understanding, what the right project is at the right time that's going to benefit both our educational goals in raising awareness about the viability of these technologies, as well as helping us meet our carbon neutrality goals.
Thank you. And with that, I don't see any other questions, so we'll go ahead and conclude the webinar for today. Thank you again to everyone who joined us today, and have a great weekend. Thank you. And thank you to our
Thanks, everybody.